So in this practice, a solid sphere is released from height h from the top of an incline, making an angle theta with the horizontals. Use the energy conservation and calculate the speed of the spheres when it reaches the bottom of the inclines, when the spheres rolls without slipping. So maybe we can draw the figures at first. This is theta. This height is h. This object starts rotating, and then finally it reaches the bottom with a velocity of v. Still keep rotating. Then we'd like to find out this speed of v. This is the questions. And then we consider radius of this object is r, mass of the m. Then moment of inertia, rolling sphere, is 2/5 mr squares. We use this equation. And then in the case of the rolling without slipping, the velocity is related r omega. Okay. So from this equation, you could use the omega is expressed v/r both ways in the case of the without slipping. Then energy, conservation of energy we can apply. Kinetic energy plus potential energy. Okay, this is energy. It's always constant. So we consider the kinetic energy is made of the two terms. One of the term is 1/2 mv squares. These are translational energies. Plus 1/2 I omega square. This is rotational energy. This is rotation. This is translation. Energy. Then we can use these expressions here. Then it becomes, and also I is here, 1/2 m r square omega squares. If you substitute here, it becomes 1/5 m r square omega. Then this is equal to v square. So it becomes 7/10 m v squares. This is the kinetic energies. So you could use the energy conservation. At the highest point, actually kinetic energy is 0. K plus U, highest point, K is 0 plus mgh. At the lowest point, U is 0, but we have a kinetic energy. K is 7/10 mv squares plus 0. You can use this equation to find out the V. So m is cancelled out. So V is expressed square root 10/7 GH. Okay, this is the answer to these questions.